I'd like to call on RICCARDO SPAGNI, who is the lead maintainer of Monero project and a member of the Monero core team. Thank you.
Hello. All right. Next. It works. So I'm going to talk a little bit about privacy today, which I know is entirely unexpected. I'm sure a lot of you were expecting me to do a stand-up comedy routine, but not today. And what I'm really going to talk about is how to analyze, how to critique, how to identify both good and bad projects in the privacy space. Obviously, the focus of this talk is largely on financial privacy, but a lot of the techniques and the suggestions and the things I'll say are useful for other privacy-enhancing projects, whether it is ways to enhance privacy in communication or elsewhere. As has been mentioned before, I am the lead maintainer of the Monero project. I'm also the co-founder of Tari Labs, which is one of the contributors to the Tari project. And I live in Plettenberg Bay, which is lovely. So, let's start. Let's start by talking about why privacy matters. And this is the part where we don't talk about tax evasion. The reason that privacy matters is because we live in a shifting landscape. So, we've got all these cool things that have been invented over the years. I mean, it started with cash and IOUs, and then we got checks. And I don't know if you remember, if you're old or older, going and paying with a check, and they had to put it in that little machine or in that little thing, and they had to, like, you know, make sure that they scratched on it so that it went through both copies. And then we got cards, and cards also had that little physical thing where they had to put the card slip on top and go chunk chunk. And we don't have that anymore because now we can tap and pay, which is really cool. Sometimes you have to hold your card there for slightly longer, and if you move it away too quickly, then the machine complains. And then we've got Apple Pay and Samsung Pay and Hawaii Pay, and every manufacturer now adds pay to their name, and therefore they have a payment system. And this is really cool because what we've gained from all of this is increased convenience. But then we have all the regulation, the KYC and the AML, because you could be using Apple Pay for something naughty. And so that has led to a decrease in privacy. And of course, most people don't care because as long as they can continue to play Farmville, they'll give all their data to anyone, no problem. But why does it matter? Why does financial privacy in particular matter? Financial privacy matters for a number of reasons. And it's not just for criminals, financial privacy is for everyone. So some of the reasons why you might want financial privacy is you don't necessarily want advertisements based on spending habits. So you don't want Google or Apple or whoever. I mean, Google's pretty bad. You don't want them knowing like what you're buying and then feeding you a stream of adverts. You'd rather they just monitor your browsing habits and do that instead. What about targeted crime against the wealthy? And by wealthy, we don't mean people who, you know, drive fast cars and have fancy watches, but we mean people who have any amount of money at all. If somebody knows that you have a certain amount of money and that you store it in this particular place, so that you're going to the bank to withdraw a certain amount of cash, well, they're going to target you. Same goes for unintended leaking of sordid purchases. Do we really want everyone at the office knowing what we spend our money on? I don't think we do. Unwitting complicity in criminal acts, this is something that's quite unique to cryptocurrencies. Typically speaking, if you receive a 100 Rand note and it's previously been used in a drug deal, you don't care. You're probably just going to use it in the next drug deal, so that's fine. But with cryptocurrencies, what can happen is you can receive funds, so you can receive Bitcoin from, you know, someone that's paying you, and if that was used in a drug deal, like, you know, a few transactions back, now suddenly you could also be a drug dealer, and that's obviously not something that you want. I mean, unless you are a drug dealer, I don't know. Miner censorship based on recipient, so miners, again, in a cryptocurrency, in the cryptocurrency space, and this works for proof of stake stakers as well, are able to create blacklists, they're able to share blacklists, they're able to censor transactions based on who it's going to. So they might go, well, I don't want Ricardo to get paid, so I'm just going to blacklist his addresses. And obviously, you know, there's ways around this, but one of the best ways around this is for the miner not to know what's going on or who's getting paid. Revealing sensitive business relationships. What about things like profit margins? What about revenue? These are all things that can leak, and it's why we need financial privacy, not just on an individual level, but on a business level as well. So what does this actually mean? I mean, if you really wanted to create a cryptocurrency that has financial privacy, how do you go about doing that? What are the pillars that you need? So I'm going to focus on 5 pillars that I think are essential for cryptocurrency privacy or for financial privacy in a digital currency. The first one is unlinkability. So unlinkability is you don't know where transactions are going to. You might be able to see the transaction on a blockchain, that's totally fine, but you shouldn't be able to identify the address, and through the address identify the person or the company or the organization. The next thing is untraceability. So you shouldn't be able to see where transactions are coming from. So if you receive a payment, no one should be able to passively look at that and say, oh, you received a payment from a drug dealer, so therefore. And then there's cryptographically valueless. No one should be able to tell the amount. So if you receive money, maybe it's your salary, no one should be able to look at that and go, oh, well, now I know how much you earn. And then, of course, there's privacy with regards to addresses, so with IP addresses. And this sort of linkability really relates to your unique internet address, which is unique at the time that you're online, and linking transactions back to that. And the last thing is optionality. So how do we maximize the privacy set? How do we make sure that our privacy set is as big as possible because everyone's using it? So what I'm going to do is I'm going to just go through how Monero focuses on these 5, just to give you a bit of an understanding, not so much of Monero, but as to how we analyze these or how we look at these 5 pillars as respect to digital currency. So let's take the first one, cryptographically unlinkable. So remember, this is where we want to make sure that we don't know who's being paid. So with Monero, what happens is we use this thing called a dual key stealth address. So with Bitcoin, you put in your Bitcoin address and you go look on the block explorer and you can see that address. With Monero, instead, the recipient or the address that's shown on the block explorer is not actually an address, it's the destination. And that's computed by taking your address and the recipient's address and doing this thing called a Diffie-Hellman key exchange and padding it with a random. And then you create this destination. And to any observer, that destination appears to be random. So in this example, where we have 3 outputs that are going to a recipient and 3 that are coming back to us as change, when we look at it on the block explorer, it looks like that. And we can't tell which of those 3 are going to the recipient and which are coming back as change, if any. We can't tell if those are going to 6 different recipients or 1 recipient with 5 change outputs. We can't really tell anything about who it's going to. Now, untraceability, how do we make sure that, that no one can see where a transaction is coming from? So we do something on inputs, excuse me, we do something on inputs called a ring signature. And the ring signature, or the way we create a ring signature, is we go take a look at the blockchain, and we have a real transaction that we're spending money from, and then we go and pick a bunch of other transactions. So in this example, we're picking just a few transactions. We're picking 6 over there, and the one in red is our transaction, so that's the real transaction where we received money and now we're going to spend that money. And the rig signature combines all of these, and it creates this little thing called a key image to make sure we can't spend that money from the same transaction over and over again. And to anyone looking at it on the blockchain, they just see this ring signature that appears to be spending from all 6 of those transactions simultaneously. And the chances of them guessing which transaction is really ours is equiprobable in the cryptographic sense, so no one can just go and be like, ah, yes, it was definitely that one, or it was definitely that one. They can't actually tell which old transaction it's coming from. The problem with this is that it's really hard to choose transactions. And this is something that I think the creators of Monero never intended or didn't realize. And we call this the output selection problem. And the reason is because people spend their money really weirdly. So, you know, typically, and I think that this is something that we can all attest to, typically people receive money and they spend it quite quickly, but then you've got these weird outliers like, oh, well, you know, I'm going to buy this and keep it for a long time, and then I'm going to, you know, I'm going to earn money, rah, rah. Or I need a store of value for a set period of time for a year, I'm not going to touch it. Or I'm leaving this money for my kids, and so they might only spend it in 15 years' time. So these outliers change the spending patterns. Now you have to construct a ring signature that appears to be like everyone's spending patterns. And that's really hard. So we consider this the weakest of Monero's privacy aspects. This is it's really, really hard to do, as I said. And there were multiple weaknesses that were discovered by the Monero Research Lab, which is this open group of researchers and academics and scientists. And they suggested a bunch of fixes to the vulnerabilities that they discovered in 2014, and the suggestions were in 2015. We made more distributions to try and favor recent transactions. And then we introduced this thing called RICCT, which I'll talk about next. And that really just it was a game changer in terms of increasing the number of transactions that could be included in a ring signature. But really more work is required. So it's important to note that this is the weakest aspect of Monero's privacy. But we'll touch on why this is okay in a moment. Now, I said that I was going to tell you about RICCT. So RICCT is this cool thing based on Greg Maxwell's confidential transactions. Greg Maxwell's a Bitcoin core developer, and he created this thing called confidential transactions. And what it does is it hides the transaction amount. And instead of the transaction amount, it uses something called a range proof, or a commitment, and then the range proof. So the commitment is basically like a cryptographic thing that says, I know the value, but I'm not telling you what it is. And the cool thing with the commitment is that you can do arithmetic with the commitments. So you can take a bunch of commitments that add up to a value without knowing what the value is, and take another bunch of commitments that add up to the same value, again, without knowing what the value is, subtract all of them and end up with 0. The trick here is, or the issue cryptographically, is that you need to make sure that no one can create money out of thin air. And in order to do that, you need to make sure that these cryptographic commitments are positive numbers. And so, hence the range proof. And range proofs are these really big, complicated mathematical proofs that prove that the number is positive. It's between 0 and some large number. So basically what happens is we then create this ring signature, or a special type of ring signature, which is a RICCT ring signature, which signs the difference between the inputs and outputs, proving that we haven't created money out of thin air. Okay, and that's the end of that slide. So basically what you end up with is that you can't see the values. You can see the commitments and you can see the range proofs, but you can't deduce what those values actually are unless you go and beat the person over the head with a hammer and he tells you. Now, being passively hidden is very important as well. So why do we care about being passively hidden? Well, Bitcoin and Monero and other cryptocurrencies are decentralized. And the way that they work in terms of what they look like on the internet is that you've got a bunch of people running nodes. And a node is just a piece of software you run on a computer. So you can imagine over here, we've got 4 nodes running on this little hypothetical network, and my node is the one in green. And those nodes can be scattered all over the world. The one in green is obviously in Plettenberg Bay, and the other 3 are scattered all over. That one could be in Iran, and that one could be in Russia, and that one could be in Kazakhstan. Doesn't matter where they are. On the internet, they're all connected, and they're connected not each to each other, but like in its entirety, but just to peers, so just to a subset of them. So what happens is when you broadcast a transaction, and broadcasting a transaction is the thing that you need to do to send the transaction so that miners can pick it up and mine it, is you broadcast it to your peers. Now, in this scenario, we have a bunch of naughty logging nodes, and those logging nodes are also sitting on the internet, and they're going, okay, this particular transaction I first saw from this green node in Plettenberg Bay, and so therefore, because I saw it first before any of the other logging nodes saw it, we can deduce that that was the point of origin within some statistical variance. And this is a thing that happens. There are legitimately third parties and nation states and so on that are currently running networks on top of, or within Bitcoin and within Monero and within other cryptocurrencies, purely for the purpose of trying to figure out what is the point of origin of a transaction, so that they have additional metadata and information. And that's obviously not ideal. So the way Monero solves this is by running something called an overlay network. And an overlay network can be done via something like Tor or I2P, which are privacy-enhancing communications networks that sit on top of the normal internet. And so then what happens is when you broadcast transactions, instead of broadcasting it on the normal internet where all of these logging nodes can figure out your real IP address, you broadcast it on the overlay network, and then by the time the logging node gets it, even if the logging node is the first one to receive it, all it gets is your address on this overlay network, which is like a .onion address or a .I2P address, and doesn't actually map back to your real-world IP address. The upshot of which is that you're hiding where the transaction is originating from. The last thing that we focus on is optionality. Now, why do we care about optionality? Whoa, that went way too fast. Let's go back there. The reason that we care about optionality is that, okay, well, just pretend the slide's up. The reason that we care about optionality is that the way privacy works is you want to get lost in the crowd. So imagine that you are wearing a red hat and someone's after you. We're not going to say who the someone is. And you're walking through the waterfront and you're wearing the red hat, but the waterfront's largely empty. Well, it's going to be pretty easy for someone to pick up the dude wearing a red hat. But on the other hand, if you are in a group of people wearing red hats, like say at a Donald Trump rally, then it'll be a little bit harder. They'll be like, the guy in the red hat, oh, there's so many of them, I don't know which one it is anymore. So that's why optionality becomes really important. So imagine a digital currency where privacy is optional. It's an add-on, it's this bolt-on extra. That seems really cool because, oh yes, we want to be able to, also do things that are traceable for whatever, regulatory reasons, or to prove that we made a certain transaction. Great. The problem with having optionality is that then your total privacy set, the total number of people that are part of the crowd that you're getting lost in, is just the subset of people that are using the privacy features. And so even if the magical cloud of privacy is the best privacy technology that's ever existed, it doesn't matter. You're still only getting lost in a crowd of 100 people or 50 people or 10 people. So what Monero and some other currencies do is they get rid of the optionality and they say it's private by default. You have to use the privacy enhancing stuff. What you can do is after you've made a private transaction, go and reveal the details. And you can do this in a number of ways. You can post the details of the transaction on Facebook if you really feel like that. Or you can do so in a cryptographically sound way. So Monero has something called a view key. And you can go and reveal that view key to a third party or to like an auditor or SARS. Or you can take that view key and if, let's say you're a charity, you could publish that view key and then people could go and confirm, well, yes, as a charity, you did indeed receive the funds that you're claiming you received. And, no one's skimmed off the top by claiming to have received less. It's not perfect, obviously. People can still find ways to cheat the system, but at least from a cryptographic perspective, that gives you the maximal privacy set while still providing some degree of optionality. So you can, have regulatory approval if the government says, no, please give us your view key or whatever. So what does this all lead to? So now you know that these 5 pillars, and you go, okay, I want to use these 5 pillars. How do you do that? So the way you use these 5 pillars, and we'll see if this slide will stay on. Oh, it does. No, it doesn't. The way you use these 5 pillars is by creating a thing like that. Okay, so what that is a thing that went off, is a table that lets you take the 5 pillars and apply them to different currencies. So I'm sure you've seen those little charts where you're trying to evaluate something and you're like, well, I'm thinking if I should date this girl or that girl or that girl, and then you put beauty, 10, 9, 9.5. No, we'd never do that. But it's similar to something like that where what you really want to do is be able to evaluate for each currency, does it have the thing that I want? Does it have maximal privacy set? Does it have untraceability, unlinkability? Does it hide the values? And does it hide the IP addresses? Wow, and we missed the last slide as well. Okay, so let's see if the final note will stay there. This is what I consider to be the 6th pillar. And the 6th pillar is really all about the way that people approach development or building that project. And this really applies to more than just digital currencies. This applies to all sorts of things. It applies to privacy-enhancing projects like Tor. It applies to private communications projects like Signal or Wire. And it's really an ideological thing. So that slide's going to go away anyway. But just to give you an idea of how Monero contributors approach developing Monero, they know that at the very least they're responsible for people's money. That you can't get away from that. You're working on software that is responsible for people's money. So you have to exercise a great degree of care. But more than that, you know that someone, somewhere along the line, is going to take like their life savings, or they're going to mortgage their house, or they're going to do something really dumb and put it all on that piece of software. And so now you're not just responsible for like a bunch of people mucking around with $10, you're responsible for a lot of money. Not directly responsible, but responsible for working on the software, and a bug that you put in might, mess that up for someone pretty badly. The third thing is, if you really think about it, you might be responsible, especially in a privacy-enhancing sense, you might be responsible for someone going to jail. And they might be innocent. You might morally not disagree with the thing that they've done. But because of a mistake that you made, or because of a weakness that you didn't speak about, they're now in jail. And the fourth thing is, really, if you come down to it, you might be responsible for the difference between someone's life or death. And that's really a sobering thought that a lot of people who are very excited about working on digital currencies don't think about. They don't think about the impact that their work can have. So ideologically, I feel, and a lot of Monero contributors feel, it's important to keep talking about how critical it is, and how mistakes can have a very far-reaching, long-range effect on a great number of people. With that sobering thought, thank you very much for your time, and thank you for having me.